Rational exponents. When we say rational exponents, what we mean is we're just talking about exponents that are fractions. We have a few rules here. The first rule is going to be the nth root of a letter A. It's the same thing as writing it as A raised to the 1 over n power. This first notation here is what we call radical notation. It can be rewritten with exponential rational exponents as a to the 1 over n power. And this actually generates a new rule for us. If I have the nth root of a to the m power, I can actually rewrite this as the nth root, in parentheses, all raised to the m power, which becomes a raised to the m over n power. And we're going to use both of these rules for these upcoming examples. Our first example is we're going to convert from radical form into using rational exponents. And we'll start with the 7th root of x is equal to x raised to the 1/7 power, because the exponent on the x is a 1, so that's the numerator. In general, what we want to keep in mind as we do this next example is the exponent on the number, or the letter, is the numerator. And the index, or the radical part, is going to be the denominator. So this next example is the 5th root of 2 raised to the 3rd power, which can be rewritten as 2 raised to the 3 over 5 power, or 3/5 power. I know this may seem weird, but it's not so bad. Let's do another example. This last example of this type is going to be kind of a long one. This is going to be the 6th root of 7 x to the 3rd power, y to the 9th power, z to the 11th power. Now we have a whole bunch of bases going on here, so we're going to rewrite this with parentheses. And this is going to be 7 x to the 3rd power, y to the 9th, z to the 11th, all raised to the 1/6 power. And we're going to use a previous exponential rule and give everybody a 1/6 power. So we end up with 7 to the 1/6 power, x to the 3/6 power, y to the 9/6 power, and z to the 11/6 power. We, of course, need to reduce any fractions that we have, so I'm going to have 7 to the 1/6, x to the 1/2, because 3/6 reduces to 1/2. Y is going to reduce. I'm going to end up with 3 over 2 power, because 9/6 reduces to 3/2. And z doesn't reduce, unfortunately. We're going to try to keep all the exponents in improper fractions and not mixed fractions. All right, let's go in the other direction now. Now we're going to start with a rational exponent. We're going to have 36 raised to the 1/2 power. Well, if I rewrite that in radical form, I end up with the 2nd root of 36. And we don't write the 2. Anytime it's the square root, we simply skip the 2. So if there's no index, we know that that means 2nd root. So we need to keep that in mind from now on. We also know that the square root of 36 is just 6. So 36 raised to the 1/2 power is just 6. You can verify this with your calculator, actually. Next example. We have 27 raised to the 1/3 power, which becomes the cube root of 27, which becomes the cube root of 3 to the 3rd power. We just need to prime factorize 27. And we'll notice this becomes 3 to the 3 over 3 power. Which just becomes 3. Next example. We have x raised to the 1/5 power, which becomes the 5th root of x. So these aren't too hard, but when we start getting negatives involved, it can get a little tricky. So let's take negative 25 to the 1/2 power. Becomes, and the negative, the 1/2 power does not apply to the negative in this case, so it's just going to be a negative on the outside with the second root or square root of 25. We end up with, it's like a negative 1 on the outside. We end up with negative 5. Because square root of 25 is 5. Alright, let's do a couple more examples like this. So if we have a whole thing like 7x raised to the 1/5 power, rewriting it, I have to give an exponent to both, or I can end up with the 5th root of the whole thing, 7x. This is in contrast to this next example, where I have 7x to the 1/5 power without parentheses. Now, the radical is only going to apply to the x, not to the 7. So the 7 will be on the outside, and that will be times the 5th root of x. Please note the difference to the previous example. Let's try this next one and maybe try to simplify a little bit. We'll take 16 raised to the 3/2 power. This becomes the second root or square root of 16 raised to the 3rd power. Now the second root of 16 actually just becomes 4. And the 4 is raised to the 3rd power. Multiplying that out, I end up with 64. We'll do a few more examples. Next, we're going to have a negative on the outside. And then we're going to have parentheses 81 raised to the 3/4 power. That's going to equal a big negative on the outside, parenthesis, 4th root of 81 raised to the 3rd power. Now the 4th root, actually let's prime factorize 81, so we end up with negative parenthesis, 4th root, and 81 breaks down to become 3 to the 4th power. And all of that is going to be raised to the 3rd power. So we have a lot going on here. We've got a negative on the outside. We have a 3rd power on the outside as well. Now, we end up with a negative. Inside the parentheses, the 4th root of 3 to the 4th power just becomes 3. All raised to the 3rd power. Now, the 3rd power only applies to the 3 on the inside. We still have a negative on the outside, and 3 to the 3rd power is 27. And there you have it. You can see how complicated some of these can get. Let's change this up a little bit. It's going to be a very similar example here. We're going to have in the parentheses the negative. Negative 32 in the parentheses, all raised to the 2/5 power. That becomes, parenthesis, the 5th root of negative 32. Notice the negative is inside the radical at this point, and then we have the squared on the outside. When we have an odd index, like 5 in this case, it's okay to have a negative under the radical. If it's an even index, like a 2nd root or a 4th root or 6th root, we can't have a negative. We end up with complex numbers, and we're trying to avoid that. Our next step, the 5th root of negative 32 actually gives us negative 2. raised to the 5th power. And then all of that is now raised to the 2nd power. We can prime factorize that. So this gives us parentheses -2, close parenthesis, raised to the 2nd power, which now we're squaring a negative number, which gives us a positive 4. Our next example, we're going to start with a fraction. I know fraction with fractional exponents can be a little uncomfortable, but we'll get through it. We're going to start with 1/4 raised to the 3/2 power. Rewriting this in radical form, I get parenthesis, the 2nd root of 1/4, all raised to the 3rd power. Now, we didn't need to write the 2 for the index for the 2nd root. In fact, normally we don't, but in this case, I wanted to really make sure that we understood where it came from. The square root of 1/4 just becomes 1/2, all raised to the 3rd power. And 1/2 raised to the 3rd power gives me 1/8, because 2 times 2 times 2 is 8. And 1 times 1 times 1 is just 1. Let's apply this to a polynomial now if we need to go into radical form for whatever reason. So in parentheses, we're going to start with 3x plus 2 raised to the 5/9 power. Changing that into radical form, we end up with the 9th root of 3x plus 2, all raised to the 5th power, which simply gives us the 9th root of 3x plus 2 to the 5th power. All right, one last example, just to make sure we have this. We have 2x plus 1 in the parentheses, raised to the 2/7 power. And we're just going to skip to the answer in this case. The denominator again becomes the index, and whatever the base is, in this case 2x plus 1, gets raised to the numerator, in this case 2nd power. And there you have it.